Hello, everyone, and welcome. I'm Filippo, and I work on the Go team at Google. It's the team that maintains the Go programming language. And today I'm joined by three of my colleagues to answer questions collected both before this show and during the live AMA. If you registered for the event and reserved your spot, you'll see a Q&A button on the right-hand side of the video. So please do follow up on our answers with questions, and we'll try to pick what we can. Now, myself, I'm the lead of the security team, and the security team is in charge of making sure that Go is a tool to build secure applications. So not just making sure that Go is secure itself, which is part of our job, but also making sure that you can use Go securely and safely to build secure applications yourself and keep your application safe.
Hi, I'm Katie. I actually work over with Filippo on the Go security team over in New York City. I came to the security team after being the tech lead of the Go module mirror and checksum database, which are tools that can help you download Go source code in a way that's a lot more secure and a lot more reliable. Nowadays, I've been working on adding a native fuzzing to Go with my team. And that's a form of automated testing that can help find edge case bugs that your unit tests might miss.
Hi, I'm Julie. I'm the tech lead of the Go web team, which works primarily on the Go package discovery site that lives at pkg.go.dev. So the Go package discovery site is a place that helps Go developers find packages that might help them in developing their own projects, and then also gives them the information that they need to evaluate and decide if they want to use these packages in their projects.
Hey everyone, I'm Rebecca, and I work on the Go developer tooling. So the Go team actually supports a backend that provides IDE-like features to most major editors like VS Code, Vim, Emacs, and Sublime. And we also maintain the Go plugin for VS Code. So I'll be talking about how these developer tools can help you write secure Go code.
Excellent. So we're going to start with a question about software reuse. It's 2021, and whatever you're doing, you're always reusing software. Now, Rebecca, how does Go provide dependency management?
So Go code is typically grouped into packages, and then related packages can be grouped into a larger module. And so a module is basically the unit of dependency management in Go. What happens is you can import libraries that are provided by different modules into your own module, and the way that you do that is by having a go.mod file at the root of your project. And that go.mod file will specify each module that you require and its version that you required at, so that way you'll get reproducible builds in your project. And actually, it's really simple to get started with Go modules. All you really need to do is run a command, a go mod init inside of a directory, and it'll create this go.mod file for you. And then the Go command will continue to allow you to download and upgrade and downgrade your different dependencies. And also, you can also get this feature through your editor, so you can manage your modules through your editor, and you don't ever have to actually manually edit that go.mod file.
Excellent. So you mentioned reproducible builds, and that is definitely something that is dear to the heart of the security team, because that means that even if something changes in the outside world, a build of a Go module will always be the same, independent, and there's no way for external compromises to influence the application after its build has become reproducible. Now, we talked about how Go modules are managed, but the next question I think is for Julie. How do I choose dependencies for my project?
That's a really great question. And I mentioned that my team works primarily on the Go package discovery site. And it was actually built for the purpose of helping developers choose their third-party dependencies. So as we're building the site, I would say that we thought about surfacing information that belonged to three main categories. And I would break these down into popularity, quality, and stability. So a little bit about each one. Popularity, I think, is important because it really just acts as a social signal. It tells you other people are using this package. They've probably already done the work for you to evaluate whether or not this package is dependable. And if the author of the package decides that they want to stop maintaining the project, it's likely that one of the many people who are depending on this project might step up and continue to maintain it. When I say quality really just means looking at the quality of the code itself. Is this project well documented? Is it well tested? And does it generally just look like quality Go code that you feel comfortable including in your own project? And I think lastly, stability. That's the topic that's probably the most dear to the security team's heart. It means figuring out whether or not this package is reliable. So security vulnerabilities is definitely one of those features. You want to look at a package and see, does it have a history of security vulnerabilities? But in general, you're just really looking at the package to see, is this something that I can not only depend on today, but months from now or years from now? And looking at conventions like Rebecca mentioned with Go modules, whether or not the author follows semantic versioning, those are all some things you want to look at when considering stability.
Excellent. Now, the next question I feel like is definitely for me and Katie. What are some new things coming to Go that will help with end-to-end security? One thing that I want to mention myself is that we are building a solution for vulnerability tracking in Go. So what we want to handle is when there are already vulnerabilities that are known in the outside world, we want to make sure that you can get to know when those vulnerabilities affect your application or any of its dependencies. So there are two pieces to this. One is that we're going to maintain a first-party vulnerability database where we track and collect all vulnerabilities that have been disclosed publicly in any Go module that's publicly importable. And then we'll provide tooling, tentatively called Go Audit, that will use the database, access the database, and then report which of the vulnerabilities that are known affect your application. What's interesting about it is that it's going to use static analysis to make sure that it only shows you the ones that are actually relevant to your application. So even if you do depend on a version of a dependency that has a vulnerability, if there is no way for your application to reach that code, maybe because you're not using that mode or plugin or setting, the Go Audit will not tell you about it, so that when you get a report, you know that you can prioritize fixing it and spend the time to figure out what it is and why. And Katie, do you want to talk about fuzzing?
Yeah, I would love to. Fuzzing is something that's very near and dear to my heart. I'm really excited about this coming really soon. Fuzzing is, like I said before, it's a kind of automated testing that's a little bit different from unit tests. And it's something that in the past has often really just been leveraged by security researchers. And while that's really great, we think that every developer who wants to use this tool can benefit from it. It can help find bugs that your unit tests might miss. And how it can do that is in its kind of fuzzing mode, it actually can run a fuzzing engine which generates inputs for you. It can do some really smart things to try to find new coverage and find new crashes. And in the default mode, it's going to work a lot like a unit test will, where you can provide the inputs and you can provide what you think it should do, and then it'll report to you if there's a problem. And there are existing tools out there right now for fuzzing in Go, but none that are built into the standard distribution or part of the Go toolchain. And that's something that we think is going to be really important to help just the general user experience for Go developers, and kind of provide a first-class service with fuzzing. So I'm really excited about this, and I'd love to answer more questions about it.
Yeah, I'm also very excited about it because indeed I used fuzzing as a security researcher in the past, but it always felt weird that fuzzing is considered this thing that you prepare once, you write the fuzzer, you run it once, you find your bug bounties or not, and then you throw it away.
Yeah.
Would you imagine if unit tests were something that somebody just writes once to find bugs in your program and then throws them away after reporting the bugs? So we do have a question from Alan about fuzzing. How long do you think it will be before the new Go fuzzing proposal uncovers bugs in hardware?
I love that question. So thanks, Alan, for asking. I think it's going to depend. I mean, in my optimistic view, I am hoping that people can start using this tool really, really soon. We're kind of on the cusp of being ready for people to start beta testing it in our development branch. So people should definitely be looking out for upcoming announcements like that. I'll definitely be posting on Twitter, so you can watch for that. But at that point, as soon as people are ready to start writing fuzz targets, they definitely should. And depending on how good the fuzzing engine is, which is what we're going to be hopefully finding out during the beta testing phase, the hope is that it can find bugs pretty quickly. What we have right now is already using what's called coverage guidance, meaning that it can actually see if there's new code coverage during the testing process and kind of determine if that's an interesting input or not. And if it is, then it can kind of focus on those inputs going forward and get smarter as it runs. And so the hope is that as soon as people start using it, they're going to be able to find these bugs.
Excellent. The next question from Jamie is about something along the lines of sandboxing. Jamie asks, are there any plans to limit what dependencies can do? For example, declaring that a dependency package can't make network calls or execute child processes. It's something that's extremely interesting to think about, and it's something that I always felt like JavaScript could really do, because JavaScript already has a full-fledged sandboxing story. Or at least it did until Spectre happened and we realized that there isn't really a security boundary between things that run inside the same process. So really, I don't think we have any plans for Go for that. Because remember that in Go, you can do things like just use unsafe and access memory directly. And although there used to be a safe mode where the compiler would try to disallow things that look a little too, that would allow you to mess with other dependencies. We never really trusted the safety of that, and it's been removed, if I remember correctly, in Go 1.12 or something like that. Our recommendation is very much more to use instead process sandboxing. For example, the Go playground uses gvisor to just sandbox the entire process and not smaller units within the process. Again, Spectre is really the problem with that kind of within process sandboxing. And too long to go into details, but Spectre is a vulnerability in the CPUs themselves, and truly a whole topic of itself. I will stop talking about Spectre because I can totally just go on talking about Spectre. Katie knows. But instead, I'll take the next question from Julian, hopefully. So how to be sure that the public Go library that I use is secure and doesn't contain backdoors or something else? I feel like this is something up your alley, Julie.
Yeah, that's a really great question. And I think I mentioned stability is really one of the things that you want to look for when you're thinking about a third-party package. So today I would say that probably the best way to do it is actually just to treat the code like it's your own Go code. So when you pull the code down, run the tests that are part of the repository. Hopefully there are tests there. If not, that's a pretty strong signal for you. And maybe even write your own tests to see if you can uncover things that you're hoping to look for. But on our end, for the Go team, one of the things I'm really excited about this year is that on the package discovery site, we're building out a version history timeline so that when you're looking at packages, you can kind of look at what the changes are from version to version for a package. So for example, is the author deleting identifiers from version to version? That's probably a bad stability signal. And then Filippo also actually mentioned that the security team is working on a Go vulnerability database. And so the package discovery site is going to be one of the places where we can surface that information for you. And so when you go and look at a package and it has a security vulnerability at the most recent version, there'll be a little piece of information there to say, just so you know, this has a security vulnerability. Be careful when you're using this package. So yeah. I'm excited for that to come out this year.
I also feel like it goes back to what you were talking about with social proof and popularity, because really reusing software always involves a trust relationship. We try to do our best to make tools to assess this trust relationship and to minimize it, but the trust relationship is fundamentally there. And something that I think makes the Go ecosystem much better suited than others to handle the trust relationship is that there is a culture of limiting how many dependencies you have. So there isn't a silver bullet to make sure that there aren't backdoors in a dependency, but the fewer dependencies you have, the fewer liabilities you have. Now, we have another question about fuzzing from Stephen. Will there be a way to seed fuzzing or trace the seed for a fuzz so that errors can be repeated? So how will I know how to repeat the failing test?
Yeah, so it's kind of two ways to interpret that question, so I guess I can answer both. As far as knowing whether or not, so I guess the first part of the question is, if in this flow, fuzzing generates an input that causes a crasher, how do we know that that crasher is actually fixed? And how can we run that crasher again in the future and check that into our repository as a unit test? What's really cool about this UX, basically, was a very intentional choice to try to do this by default for the user. So if you were to run go test -fuzz and then specify your target, and it'll run. And then if it finds a crash, it'll actually print out, hey, we found a crash. We wrote it to test data for you. And here's the name of the file. And to run it again on that specific C corpus in the corpora, you could actually just run go test -run fuzz whatever and that file, or you could just run go test and it'll just include that as a normal unit test. So basically it can go from fuzzing to just being a unit test without you needing to do anything at all. And I think that that's a really important part of the UX. And if you were to interpret the question instead of like actually running it the same way every single time for debugging, there is actually a way to do that too that we're looking into, where you can actually provide the seed for randomness, but that's probably not something that most people would benefit from. That's more just for debugging the actual fuzzing engine.
I played with the flow that Katie is describing, and I was extremely happy because, the fuzzer finds something, and usually with other fuzzers, you have to then write more code to try to run the fuzzer input into your program to figure out how that happened. And instead with this, you just run go test. And it fails again. And then you try fixing it and you run go test and it fails again, let's be honest. And then you keep doing this a few times. And eventually the test passes and you know that that worked and you did not write one more line of filler code or a boilerplate. So yes, I'm extremely excited for this. Now, a question from Peter. Rebecca, I think this one is definitely for you, and is what is the best ID for secure Go development? I feel like more than what the best one, we can talk about what they have in common too, because I know that there isn't that much difference in what runs underneath, right?
Yeah. So basically the two most popular editors or IDEs for Go development are VS Code and Goland. And Goland is a JetBrains IDE, so I won't really be able to speak to that, but I can speak to VS Code and Vim and Emacs and all the other editors that the Go team does support. And so as I mentioned earlier, we have gopls, which is the backend that provides IDE-like features for all of these editors. And it has all the same features across the board. And so linters that are available through gopls are available in VS Code, Vim, Emacs, all the same. But since VS Code is the most popular editor, the Go team also supports the VS Code plugin for Go directly. And it does have a few additional features that community members built in before the Go team sort of took ownership of it. So it has a little bit more linters that are just built in by default. Things like Golang CI lint are available directly in VS Code Go plugin. So that can be useful and help with security. But in general, VS Code has a few features that are really nice for security as well as that. So right now they're doing something called trusted workspaces, which basically means that you can indicate that you trust a workspace and that'll allow you to run arbitrary commands in there. And we've just been in general careful about a lot of the Go extensions. They run the Go command under the hood. And so we've been a bit more careful lately about making sure that we check that the workspace is trusted before we do that.
Anybody paying attention to the security updates might have noticed that that's actually something that's fairly hard. In Go, we have this security model where we consider looking at code and building code not the same as running it. Other ecosystems just don't have the distinction, and that's a design decision. But in Go, we guarantee that downloading a dependency, building it, opening it in VS Code Go is not going to execute code from it. And that's something that we really like for triaging vulnerable code, because it means we can open random code from the internet without being worried about that code trying to run something in the background on us. Now, we have another question that we got before the session that I feel like dovetails well on that. Does Go have a debugger? And what are upcoming new features for debugging?
Yeah, absolutely. So Go has a debugger called Delve, and it's had it for a long time, though. I know a lot of people often don't actually, they may not be aware that Go has a debugger, but you can access it through any of, there are plugins basically for all these editors like VS Code and Vim, etc. But there's a lot of new stuff coming in this area. So actually, the way that Go Please works, the IDE backend, is that basically it speaks the language server protocol, which basically all editors can speak it, and the language server provides these features, and that's how they communicate. So there's a very similar thing for debuggers, actually. It's called DAP, it's a debug adapter protocol. And so Delve is getting, basically one big thing that the tools team is doing is working on adding DAP natively to Delve. So basically, this is going to be a debug adapter implementation directly in the debugger, and it's going to be coming out shortly. I think it's available right now in an experimental mode, but I think it'll be enabled in a preview version of the extension by default pretty soon. And so you can try that out in VS Code Go. And what's really nice about that is it's sort of previously this debug adapter had been written specific to each editor plugin, just like the same thing for the IDE integrations, like what Go Please kind of solved. So basically now there's going to be a Go implementation of this protocol, and any editor can use it as well. So basically debugging should become a lot easier for you soon.
That's awesome. I knew about the language protocol, language support protocol. Is that right? What does LSP stand for?
Language Server Protocol.
Language Server Protocol, yes. And I knew about that. I didn't know that there was an equivalent one for debugging. And that sounds great because, again, that was so much duplicated work between each editor and IDE having to integrate with all of the tooling, or even worse, rebuild all of the tooling. So that's excellent. We have another question from Stephen about fuzzing. So will fuzzing be more than just type registries with candidate values per type? What kind of smarts are in fuzzing? And I think Stephen here is probably asking about the mutator, I guess. What do you think?
Yeah, I'm actually not sure what a type registry is, but I can definitely talk about which types will be supported and kind of how the mutator will work in that way. So right now in basically the development branch that we're working in, it's just supporting basic types like a byte slice, a string, an int, a uint, a float, things like that. And all of those things can be mutated in the mutator and spit out new inputs based on the values in the corpus. And in the future, we also want to be able to support more types, just generally speaking, like an int slice, for example, things like that. But we also want to be able to support struct types in the future. So that doesn't necessarily mean we're going to support every single struct right away. But what we can do at the beginning, at least, is to just support structs that basically have an implementation of the text marshalling or binary marshalling interface. And so what we can do is then just mutate the bytes under the hood and then just unmarshal it back into the struct value before we run it against the fuzz function. And that's something we hope to have as well. And more details on that as far as like how it works under the hood and what kinds of things are going to be supported, you can see better on the design draft that's online. That's at golang.org/s/draft-design. I think it's draft-fuzzing-design. Or you can just Google it. It should come up pretty quickly.
I hear this Google engine works pretty well. Now, we talked about stability for a second earlier. What are some features on pkg.go.dev that can help me evaluate if a project is stable?
Yeah, that's a great question. So on a high level, on the right-hand side of every package page, you'll see this little detail section. And that'll tell you if you're looking at a stable version of a package. And so if the author is following Go module conventions, then a package is expected to be stable once it's been tagged with the v1.0 or higher release. And then additionally, if an author decides to retract their package version or the entire module has been deprecated, you'll see a bright yellow banner across the site that tells you, you probably don't want to use this package. We also have some features on our roadmap that are going to help developers evaluate stability. So I mentioned earlier about showing more about the package API history from version to version so that users can see if the package API is going to change across different versions. We're also planning to surface information from the Go vulnerability database. And lastly, also more information about whether or not specific identifiers are deprecated within the API itself.
And we got another question that I feel like is paired with this one. Why do Go modules require Sandboxing semantic versioning? Because you mentioned V0, V1, and maybe you can say a little more about what semantic versioning is and how it plays into APIs.
Yeah, definitely. Semantic versioning is basically just a convention that is used not just in Go, but specifically with Go modules. It's a way for the author to be able to indicate the level of stability that you can expect from this project. And so if it's V0, then it's expected that the author might be causing changes in their API. They might potentially be deleting an identifier from version to version. Effectively, this package is not stable yet. And because it's V0, the author is following the convention of indicating to its users this is not stable. Whereas once you get to V1 or higher, then something that you want to be able to do is make sure that from version to version, you're not breaking your users. So say I'm using a function foo in 1.5.2, I don't want to download 1.6, and then all of a sudden the author deleted the identifier and I can't use it anymore. And that's also why Go has this a convention of using deprecations and adding a deprecated comment when an author doesn't want you to use an identifier anymore, but it should still be there in case a user was depending on that in a previous version. And I think the last piece of this is really just major versions. And so if you have a change between V1 and V2 and V3, it's expected that it's possible to have breaking changes between different major versions. And so Go actually has semantic import versioning so that the import path changes to indicate this to users as well.
Yeah, the point about multiple major versions is, I think, something that comes in very handy when you end up depending on something that depend on two things that depend on two different major versions of the same thing. This is usually called the diamond problem. And in Go, that problem is just solved by the fact that you can have two different major versions of the same module in the same build. And if they don't have the same major version, then they need to be compatible. And if they're compatible, you can just use the most recent version. So if two things depend on V1, we'll just pick the newest version. And if a thing depends on V1 and one on V2, we'll just have them both available. That's just one of the design bits of modules that I always really liked. And you also answered part of one of the questions that we got earlier that is about the crypto libraries, which is how often do you have to deprecate older crypto libraries, and do these deprecations break older versions of Go? So there are two places where we have crypto libraries, and for context, Go comes with a complete set of cryptography libraries, including things like TLS and encryption and signatures. We do deprecations. We did a bunch of deprecations in the last few years, partially because the libraries are almost 10 years old. And we want to make sure that anything that you find in these libraries is something that you would want to use and that is modern enough that this is not going to be a foot gun. So we do deprecations, but deprecations are just surfaced through tooling. They will just, for example, show up in your editor saying, hey, you're using this thing that is deprecated, and here's some text that explains the deprecation, and here's what you can use instead. And they absolutely never break Go code, whether they are in the standard library or in the Golang org x crypto repository, because both of them follow the Go backwards compatibility promise and Stambler, so make sure that they're always backwards compatible. So we use deprecation instead to communicate about things that we kind of wish weren't there, but we're going to keep them there because we don't want to break anybody. And it's fine. Okay, so our time is, I think, running out. So we have one last question, which I think everybody could answer. What is one thing you would recommend checking out for Go? Katie, do you want to start?
Yeah, so one thing I think that's worth checking out is go.dev. This is something that Julie could also probably care a lot about. But go.dev is going to be kind of a new way to explore Go. In the past, everyone went to golang.org to read about it, but go.dev has a lot of cool things like case studies and information about how it can be used. And so if you're an enterprise and you want to look into adding Go, that's a really good place to start.
Julie?
Yes, go.dev. It's very near and dear to my heart, so I hope that everyone checks it out. But I think one of the things that I've really loved about building the Go package discovery site is actually just discovering some really amazing packages for my development workflow. And some that we use all the time is Static Check, which runs static analysis on your code, and it's caught tons of bugs and made improvements to my code. Unparam has helped me catch a ton of unused function parameters and results in my code. Misspell has helped me catch a lot of commonly misspelled English words. And so those are some packages that I really love and use all the time and recommend checking out.
Yeah, those are excellent. Rebecca?
Yeah, for sure. Static Check is available in your editor, so definitely use that. But I would recommend checking out the Go Playground, which is a sandbox where you can basically play with Go code and without having to have anything on your computer, and you can have multiple files. You can use third-party dependencies in it. It's really awesome. It's a really quick way to just write something if you want, just a scratch project.
Wonderful. So on my side, something that I used just a couple days ago is this package called AirGroup that you can find in the Golang org xsync module, which allows you to run in parallel a number of Go routines. And just when one of them hits an error, all of them get canceled and the error gets returned at the end. I find it just such a nice way to build parallelization into the programs. Now, this has been fun, and we didn't get to all of the questions, but we will try to answer them in the Dory. And if anybody has any other questions, you can always reach the Go community and the Go team on the Golang Nuts, like in Peanuts, mailing list, and on the Go First Slack. Thank you, everyone, and have a great rest of the conference.